Okay, morning everybody. On to the next session. So I'm Sean Flack, one of the systems engineers here at Arista, and I'm going to give you a bit of an update on EOS over the past year or so. So, cool, it works. So, bit of an agenda. First of all, EOS kind of housekeeping, explaining a few concepts that I'm sure those who are familiar with Arista and EOS probably know, but just a bit of a recap. And then talking about some of the kind of the evolution of EOS and some of the new features and functionality that we put in the newest versions of EOS as well. And then to carry on from that, going from our last session, which is around Q2 last year, and the features that we put in since then. So we're going from EOS 4.24.1 F to 4.27.0. So again, if you know EOS and you're familiar with the versions, that will ring a bell. And then covering off hardware, software, and then reviewing a few of the useful features as well, and going into a bit of a deep dive on those too. So EOS version. So when you go to download a version of EOS, you will see that they are all numbered with a letter at the end. F is for new features and M is for maintenance. What this means is that the F release is the only version that we add new features, right? The M release is where we maintain the code version. There are no new features added to the code version, only bug fixes, right? So the idea being is that these are the M releases are perceived as the most stable versions of code because no new features have been added to it. So generally, the recommendation is to go for the most recent M maintenance release, which is currently 4.25.1M. I realize I'm looking up there, but I can see it down there. And then, yeah, there is actually a guide online that will tell you about the lifecycle policy and how and which version of code release to choose. But at the end of the day, if there's something that's not clear, please refer to your own systems engineer who can give you some guidance. So, next. There we go. Probably going to jump ahead now. Cool. Okay, so you'll also see when you download 32-bit images, or at the end of the code, it's a 64-bit or EOS 64 in the code name. A lot of questions here. Why? Which one do I choose? I think a lot of customers, a lot of people automatically think download the 64-bit version. It's better, but honestly, there's no real advantage to that unless you have a use case for it. So the 64-bit image allows for large routing or routing information base, or RIB. So basically, if you're downloading lots of copies of the internet routing table on some of our edge router platforms, the 64-bit image allows us to fit multiple copies into the memory because of the larger memory footprint that 64-bit images allow. Again, talk to your SE if you're not sure, but generally speaking, go for the 32-bit image. There is no advantage of going for the 64-bit image unless you're using this for kind of an edge routing use case, right? Underneath, it's still actually 64-bit, the kernel. You can still run 64-bit RPMs on there, but EOS itself, some of the packages there, or most of the packages there, are still 32-bit, and therefore the memory footprint is much smaller, and you actually get benefits from using the 32-bit image. This isn't being very reliable. Okay, there you go. Okay, so EOS lifecycle, roughly speaking, it's a 36-month support cycle. So as soon as the first version of an image is released, say 4.24.0, it will last for about 36 months until we end of life that version of code, and we're no longer bringing out new fixes for it. But again, this is available online. Look on here. I'd rather go into some of the feature details instead. So I'm going to switch to this. There you go. That's much better. And again, like I said about the 36-month life cycle, as you can see here, a few examples. Now, 4.21 train has reached end of life. So if you're using 4.21 or prior, take into consideration that that's officially not supported anymore, right? So we'd really recommend that you upgrade to a more recent version of code. And like we said before, 425. And as you know, with EOS, it gets more stable the more recent the version of code as well. So roughly speaking, what do we see in terms of EOS distribution? Where do we see customers? Primarily at the moment, they're probably around 424, 425. We'd hope more people are moving to 426. But yeah, 425 is probably where we want to see you, a code version we want to see you using. And yeah, I can imagine there are some people in the room that are a bit before this, but yeah, please try and upgrade where you can. And again, why, when and why do we upgrade? Typically speaking, if you need the newest features, go for the newest version of the F release, which is 427. But generally speaking, go for the most recent M release, which again is 425.51M. There will very soon be a 426 M release, maintenance release, and we've already released 427.0F. And again, where do you find your release notes? On the download page. If you go to arista.com, support downloads, and you go to the version of code, you will see under there the release notes that you can download. Or go to eos.arista.com/TOI, and this will give you some more information about the features that there are in the particular version of code in a bit more of a deep dive, right? So rather than just saying feature, version, it kind of gives you a bit more of an explanation of what's going on in terms of the new features in that version of code. So, where are we? 16 months down the line since our last update, we have released 1, 2, 3, 4, 5, 6, 7, 8 versions of EOS. Prior to that, lots of new features that we covered off in the previous version of Cloud Builders. And just a bit of a recap here of some of the features. And I think some of the ones that we called out were around the likes of configuration locks, interface profiles, MSS, we'll talk about a bit later on as well, and a few other features too. But if I go back to here, as I said, 6 new versions of code, and you can really see here where a feature release turns into a maintenance release. So typically speaking, it goes 420 something, so it's always a 4. Don't know when it's going to get to a number 5, but it's always been a 4. And it typically goes 425.0F.1F.2F, and then that will turn into an M release. So 420 something .3 will become an M or a maintenance release. And then carrying on, the pattern continues to 426, and now we're already at 427. So I hope that's all clear in terms of choosing versions of code and where we are today. Lots of new versions of code, lots of new features. So just again, bit of a recap on EOS as an operating system, right? The foundations of it. Again, a single operating system or a single binary image across every platform that we have. And I'm sure many people know that in the room. But regardless of the switch being a 1 gig 24 port device or a 500 port 400 gig monster, it's the same binary image across the board. This is also programmable. As you know, lots of APIs, lots of ways of controlling the switch, not only via the CLI, but via the various different kind of hooks into EOS that we provide. Always using and always dedicated to open standards wherever we can, well, pretty much everywhere nowadays. Whether that be via BGP, EVPN, which I'm going to talk about a bit later as well. Lots of automation support, as we mentioned already. Quality is obviously a big, well, probably the most important part of EOS, right? So this ability to test every feature against every test case that we've ever written from the beginning of writing EOS every time we bring out a release. Every single time it goes through that auto test cycle to make sure that the most recent version of code is the most stable and the most reliable. And of course, underneath we have this state-oriented architecture, this kind of push or this publish and subscribe type model, which means that every process in the box is completely separate and cannot cause any issues with any other process on the box too. So again, some of the benefits of EOS, as I mentioned, open standards, publish-subscribe model, automation around some of the APIs and the net DevOps approaches that we have in the box as well. Telemetry out of the box too. So as per the publish and subscribe or the state machine state database, we can easily hook in telemetry by then subscribing to pretty much all states or whichever state we're interested in, convert that to a format that we're interested in, maybe OpenConfig or GNMI or whatever the streaming telemetry format might be, and then export that to your collector, to CloudVision that Paul and the guys spoke about earlier, and then present that in a meaningful way. And of course, because of the architecture, we have this ability to add on third parties or third-party integrations very easily too. So lots of different ways that we package EOS, either as the regular image, as a VMDK, or a virtual image that you can download and use in your laptop. Anybody can register for this online on the website, download the image and install it onto your laptop or ESX or whatever it might be, and start using pretty much every feature that we have in the hardware switches on your laptop in a virtual topology. Containerized EOS, very similar to vEOS, but in a format that works on Docker or as a container. And then finally, we have now what we call Cloud EOS. This is EOS running in a cloud provider, AWS, Azure, GCP, to provide a number of different functions on there, primarily around IPsec encryption from site to site, multi-site abstraction, I want to say, or connection between the two, NATing, kind of a bit of a replacement for the native switches that you get, or vSwitches that you get from the cloud provider as well, but giving you the same look and feel as EOS from a CLI perspective and from an API perspective as well. EOS evolution across the network, so lots of different use cases that we have now, whether that be data center and campus, more traditional, the core, the edge, the cloud connectivity, the carrier edge that I'm sure some of you are starting to see us, well, I say starting to support more and more. We've been doing this for a number of years now, a full MPLS service provider type feature set as well. And then also more of a specialist type use cases in, say, the broadcast industry around peering, big data, and monitoring as well. I do want to get onto the features. So yeah, more about the whole overall. How does EOS slot into the unified cloud networking design? Of course, it's fundamental to everything that we have here, but then this also feeds into CloudVision that the guy spoke about earlier, and then allows us to provide campus offerings, Wi-Fi services for IoT devices, and monitoring, whether that be with Awake or whether that be with our DANS monitoring solution as well. So what's new? This is probably the bit that I wanted to get onto, really. So what's new in EOS? Lots of new features. We're going to go through every one of these one by one. So listen up. So in the last 12 months, so honestly 14 months it's been since our Q2 Cloud Builders last year, there have been over 500 new features. That's from 424.2F to 426.2F. When I was making this presentation, they actually released 427.0, so this goes up to about 600 new features that we've released in that point in time. Admittedly, a lot of these are incremental updates to a particular feature, but it just shows shows the feature velocity that we have at Arista. And this is across everything from data center to core routing, campus storage, broadcast ECI, cloud EOS, and also visibility. So yeah, have a read of that offline maybe. But in addition to all those features, we now support a number of new hardware products that we've brought out since then. And I hope that Chris covered off most of this earlier on. Didn't quite see it, but hope he did. So from a spine perspective, we brought out the 750X chassis, which is a 5 or 8 slot PoE RJ45 device. We brought out the 7816 or 16 slot chassis that I'm sure everybody needs, that has 500 ports of 400 gig in a very power efficient, hugely dense device. And again, going back to what I was saying earlier, EOS runs across the board. So whether that's the 1, 2.5 or 5 gig campus PoE box, or whether it's the 7816 device, it's the same image across the board. At the bottom, we have kind of the leaf devices that go all the way from 1 gig up to 400 gig. So we have the 750 XP, the 96 port 1 gig box, 2RU, the 96 port Trident 3 or 7050 SX3 box. And then on the right-hand side, some of our deep buffer, high capability, kind of high feature set, MPLS type boxes in the flavor of the 70-80 CR3 and CR3MK, which is, I think, released already. But that's a MaxSec, high density, 400 gig capable routing platform as well. And in addition to that, a number of different optics that we've released as well. So a number of different 400 gig optics. The line system that we have for 400 gig that allows us to multiplex multiple 400 gigs into a single fiber, all driven from a single device. So, of those 400 or 600 features, I should say, I've picked out a few that might be interesting to some people in the room. You'll always see us, well, lately, it seems to be EVPN, EVPN, EVPN. There's lots of new features being added over the last year or so. So why EVPN, right? So EVPN as a control plane is a simplified way of providing many different services, whether that be kind of pseudo-wire type connectivity or cross-connect type connectivity, VPWS, so virtual private wire services, layer 2 VPNs, layer 3 VPNs, Metro Ethernet type offerings as well, inter-AS option A, B, and C, integrating from one EVPN domain to another, whether that be over VXLAN or MPLS. Lots of new features are being added here, have been added over the past year or so. So, some of the highlights of this. And these two will be covered off in the DC design session later on. But two of the most important ones here is the EVPN, VXLAN, and MPLS layer 3 gateways that allow a device to operate in two different EVPN domains and then also optionally convert the encapsulation from one to the other. So you can have VXLAN, say, within your local DC, and then have MPLS out on your WAN or your core infrastructure. And rather than having a handoff between the two, you can do the conversion on a single device. So it gives you that ability to stitch EVPN domains together and also stitch between VPN v4 or VPN v6 domains into EVPN. And then, of course, multi-domain layer 2 EVPN, which, it can be used for DCI, but is actually quite useful to scale large EVPN designs as well. And I'll be explaining that later on too. So a few kind of nice features in EVPN in 424.1f is this ability to have an IP version 6 underlay for VXLAN EVPN. So kind of says it in the title. So what this allows us to now do is have EVPN encapsulated by IP version 6, and within the encapsulation we can add IP version 4 traffic or IP version 6. So this is quite up till now, over the years, we've not had this ability to actually have VXLAN or VTEPs addressed as IP version 6. But now we've added this support in the Trident 3 chipset, which is the 720 XP, the 7050 SX3, and 7050 CX3. But a bit of a snippet here of the configuration, not so easy to see, I know, but effectively we address the loopback with an IP version 6 address, and then under the VXLAN configuration we specify that the encapsulation will be with version 6. So for those that would like to move everything to version 6, this provides you with a mechanism to do that. In 424.1, it doesn't support the ability to communicate with version 4 VTEP, so you have to have all version 6. But there's a way to fix that I'll come on to in a second. Before I do, it's also possible to use RFC 5549 with the version 6 overlay traffic. So what this allows you, or I should say, typically the problem with VXLAN, more so in a very large environment, is the fact that you need to address every point-to-point link and every loopback you do, but every point-to-point link in an environment. So if you imagine you getting to, say, 50, 100, 150 VTEPs, all of them with multiple uplinks and downlinks, trying to address the underlay becomes quite interesting or difficult in order to do this. So what RFC 5549 allows us to do is create dynamic BGP peerings using the IP version 6 link local address and completely removes the need to use IP version 4 in the underlay. So basically, you don't have to address your underlay at all. You just use the IP version 6 addressing or point-to-point peerings, and BGP will automatically create those peerings. And then over the top, you can then peer EVPN to provide the services on top of that as well. So I hope that made sense, but this is very easy to configure. There's not an example here, I apologize. But there are ways of automating this with the likes of CloudVision and the studios that we spoke about earlier on too. So a quick output here, it says that there's an IP version 4 address there. So if you do a show IP route VRF 10 and A, it says there's a BGP entry for 10.254.0.0/4, very large network, and that's via VTEP. And rather than it being an IP version 4 address, you can see it's a version 6. So we're actually doing IP version 4 over IP version 6 in this case. And it can also be can be used to encapsulate just IP version 4. So you can use IP version 6 as the underlay purely and have IP version 4 over the top. So it doesn't mean that you have to actually be using version 6 in your overlay. You can just leverage the ability to do unnumbered interfaces in the underlay. So I hope that made sense. And then finally, to bring all of this together in 426.0, we allow a dual stack underlay. So we allow there to be IP version 4 and IP version 6 VTEPs communicating with each other. The primary use case for this is migrating to version 6. So what we do is that we first of all start off, imagine, with IP version 4 VTEPs. We then configure the VTEPs as IP version 4 and then say the new VTEPs as IP or as dual stack. So they're configured with both version 4 and version 6. And then as we migrate, we get to a point where every VTEP is running a dual stack v4, v6 address. And then we can start to decommission our version 4s. And then eventually we get to a point where everything is running v6 as the underlay. So this provides you with a seamless way of migrating from version 4 to version 6 in the underlay, combined with the RFC 5549 I spoke about a second ago, and combined, of course, with the version 6 VTEP support for VXLAN. Few other features, I know I'm rattling through these, but EVPN STP superroute. So why? So when using EVPN all-active multi-homing, the devices are running spanning tree independently. So all-active multi-homing allows you to have a server or an end device dual attached to two different VTEPs that don't have a peer link between the two, but they advertise or can advertise the same port channel down to the end host. Problem being, each one of those VTEPs or each one of those devices will be advertising their own or operating in their own spanning tree domain. Therefore, devices downstream connected to two bridge IDs upstream over a port channel might not like that, right? So to get around this, or what might happen is that one of the devices becomes a root device and the other one becomes blocking. So what the super root feature allows us to do is advertise the EVPN domain as the kind of guaranteed root device. So we advertise it with a bridge ID of all zeros and a 1 at the end, and a bridge priority of 0. So if you look at the spanning tree output, it looks a bit strange. It's all zeros, but it's done in a way to ensure that the domain becomes the root of the spanning tree setup. And it's supported on all platforms too. And it's a very easy configuration. You just type in here, spanning tree root super, and you will change the spanning tree in your entire network in one go. So there you go. But in all seriousness, it will help you in an EVPN layer 2 domain when you're trying to make sure that this new domain is the root of the network. A couple of other another feature that we've added as well is BGP PIC Edge. So PIC is prefix independent convergence. Edge for EVPN VXLAN. What is this? So problem being, if a VTEP fails, BGP or the IGP has to converge underneath in order to work out that the VTEP has gone away. During that time, during that transient update, there's going to be traffic loss. It might only be for a very short period of time, but still some customers do not want to drop any traffic at all. So what BGP pick Edge for EVPN does is create a BFD session between the VXLAN VTEPs, and then they monitor each other. If the BGP peering goes down, or BFD detects that the VTEP has gone away, we then have already programmed within the FIB, within the hardware table, a backup path, which means that when that entry disappears, we immediately start forwarding on the backup path without dropping a single frame. So it will go, right, backup path is there, next frame send to the backup entry within the hardware, and we're able to get around that failure. Now, EVPN will eventually converge. It might take a second or two, but during that transient change, we ensure that no traffic is dropped. It's fairly easy to configure. You just type in BGP additional paths install under BGP. That will cause the hardware to install the backup paths. And then under VXLAN, we configure a couple of commands here to create the BFD sessions using RFC 8971, which then creates that dynamic BFD peering between every peer in the underlay. Private VLANs and VXLAN with EVPN. So this has actually been not very easy to achieve, but we've managed to, or we now support the ability to do this, right? So private VLANs typically only happen or typically only work in a traditional, say, spanning tree or traditional layer 2 network, right? You have the concept of a trunk, or was it community trunk, or a promiscuous trunk in private VLANs. But when we start to then try to expand this across a VXLAN infrastructure, because of the way that the layer 2 is encapsulated within layer 3, it becomes quite difficult to transport the tags for private VLANs to work. So what we've done is now able to support this, right? So we can have this concept of a private VLAN spanning multiple top-of-rack devices within an EVPN domain. We can have isolated VLANs, we can have community VLANs, where those within the community VLAN can speak to one another, but cannot speak to an isolated device. An isolated device cannot speak to any other isolated device, but they can all speak to the shared gateway. They can all speak to the default gateway on the device, which is distributed, and now we achieve private VLANs across the infrastructure. This is only supported on the Trident 3 chipset, so 7050X3, or the 720XP, which is a PoE device, which means in terms of use cases, quite popular to be able to be used in the campus as well, where people need, say, wireless APs not to be able to talk to one another. They want that to be isolated to the AP, or where they want the clients connected to the APs to not be able to speak to one another either. So support for that across EVPN. So edge routing features. And before I get onto that, I've been throwing lots of features at you. Any questions so far? There's a lot there. Okay. How are we doing? Okay. So edge routing features that we've added. First of all, EOS routing control functions. So this is a new policy language that we've implemented for manipulating routes on a device, or kind of as a replacement for route maps. So this makes it very kind of easy to program quite complex route policies in a kind of a programming-like language, right? Mike is going to be explaining this in much more detail later on, but it has this ability to provide filtering logic, modification logic, and like I said, programmable and flexible as well. This was initially introduced in 4.24.1, but we've been incrementally updating that in the most recent versions of code as well. Just a quick look at how this works, right? And like I said, Mike will be explaining this in more detail later on, but we have this kind of, start off with a code function, We create our functions. We then have this kind of if, then, else type statement format, which then allows you to build very complex root policy language into EOS rather than using kind of very, I guess, overlapping or very large root maps that you might have seen before. But like I said, a bit more detail later on. General features as well. So covered off EVPN, a bit of routing function. There's not a whole lot there, but general kind of usability and more useful features that we've added as well. So postcard telemetry. I think Paul mentioned this earlier on, and the way that we can display this within CloudVision. But postcard telemetry allows us to export per flow telemetry information on every hop of the network. So it allows collectors to receive flow information about traffic running over the network. So what will happen is that at every point across the network, flow information is then encapsulated within GRE and sent to a collector containing the sample. The header of that flow will also contain information like latency information on that particular hop in the network to then allow the collector or the analytics engine to provide very, very fine grain and very highly accurate information about a particular flow. So we can see how long did it take for that flow to pass through a device, or then how long did it take for a flow to get across the entire network. And as the flows are running, you can kind of, if you're using CloudVision as your collector, you will get all the flow information there, click on a flow, and then it will tell you this flow has passed through device A, B, C, D in the topology, as you can see there. And then you can work out how long did it take to get across the network, were any frames lost, and where did it end up or where didn't it end up at the end of the day. Fairly easy to configure. It requires PTP sync to be configured across the network in order to get the very high accuracy latency measurements. So that might be a bit of a kind of a blocker for some customers in terms of wanting to configure this, but it's fairly straightforward, right? You configure your interfaces as PTP enabled. You do need a grandmaster or something providing a clocking reference, but technically speaking, you could use one of the Arista boxes for this as well. And the actual encapsulation is green T. So what this means is GRE encapsulated span, or green T, for kind of exporting the information there as well. InfluxDB, native streaming. This is now configurable via a monitor command, so monitor telemetry influx with a destination. And then we can collect data with the Telegraph on-box collector, and then kind of an off-box InfluxDB instance if you want to then send that outbound. Today, the subset is quite small of data that we're actually exporting, mainly about the CPU disk usage, but then there are some inputs that we have today using our OpenConfig API around temperatures, fan speed, power supplies, and interface counters. I believe we're going to be adding more in time, but today it's quite a small subset of the telemetry. If you want everything in terms of telemetry, have a look at the GNMI connectors that we have. Use CloudVision, but it's there as an option, right, to kind of bypass CloudVision and send to an InfluxDB collector that you might have. This is quite nice. 426.1 added this ability to create a support bundle. So in one single command, we can collect a show tech, we can collect log files, we can collect core dumps, hardware information, lots of the commands that TAC would usually ask you to collect in one go. So you type in send support bundle, and then it can be sent to any destination that you usually have on the box, SCP, FTP, TFTP, whatever it might be. And also we have this ability to add an SR number onto the command as well. So if what I mean by SR is a service request number. So if you call up TAC with an issue, you'll get a case number. You can then specify the case number at the end of the command, and it will then rename the zip file with the case number as well. So you get one packaged troubleshooting file that you can send off to TAC, and they've got everything you need in one go. So if you're going to open up a TAC case, please run this command first. open the tag case with the file attached, and they will have pretty much everything they need from the get-go. Finally, I think we're kind of toward the end of this. Yeah, so radius over TLS. So another command or another feature that we've added is the ability to encrypt radius command or radius communication over TLS. Fairly easy to set up. I know quite a few customers have been asking for this. But effectively, you configure the radius server host with an IP, the VRF that you want to put it into, and then specify the SSL or the TLS profile that you want to add onto the radius session. And then from there on out, everything from a radius standpoint is encrypted. So I know a few customers have been looking for that too, and that is in 426.2. So there you go. There's a lot of new features there. Any questions at all about that? I've covered off a lot. So just to recap, there was the EVPN features, lots of stuff added there, mainly around the private VLANs, and some of the other features there too around routing and some of the usability features too. But any questions at all? Ivan, go ahead.
For the telemetry stuff, will there be more endport, end-type destinations?
You mean actual things, yeah, actual telemetry that we're collecting, as it were?
So the influx?
Yes, yeah, that's the idea, yeah.
Sorry, so rather than, for example, influx, we have to use Kafka
yeah.
as a message passing into influx.
Right, got you. So, good point. So, InfluxDB is kind of a native support out of the box. It is possible. There is actually on our GitHub repository an open config to Kafka connector. So it will allow you to send open config via GNMI to a endpoint. By running the endpoint that you find on our GitHub repository, it will convert that open config data into Kafka and then send it directly into your Elk instance or whichever collector you've got. So yeah, I would say do it that way if I were you. And you're able to filter and say, you probably don't want every single output on every single metric, but you still have that ability to convert it as well. Yeah. But hopefully we'll be adding more to it down the line as well. But, yeah.
So with this InfluxDB implementation, are you actually storing it on the device, just like it was on the MOS with a local instance as well? Or?
Yes, that's why we're doing it. Yeah. Yeah.
Shipping it out, is the native telegraphs shipping it out?
Yes. Yeah. Exactly. Yeah. So the question was, is this is this being implemented like the support that we had on MOS, which is our Metamako operating system? Yes, that's pretty much why we're doing it. So we have this capability within EOS now that we had on MOS. Yeah. Go ahead.
Going back to the postcard telemetry.
Yep.
So is that synthetic traffic that you inject in order to monitor it, or is it your production traffic?
That's production traffic.
So basically you know that a packet with these identifier comes
Yep.
in and this is when it's traversed these.
Exactly. Yep. Exactly. Yep.
Do you get ports information out of that as well, or?
You do.
I'm
Yes.
thinking about, for instance, when you've got lots of lag members or lots of links in the network where you get one that's faulty.
Yep.
And everything.
Oh, you mean like interface information where it passed?
Maybe, yeah.
Okay, so not, yeah, sorry, I was thinking like layer 4 ports, but no, interface information, I believe you do, yeah. So I'd have to double check. So actually it'd be down to the I have to double check. So it might be down to the IP fix configuration, but that is whether or not the header of that sample contains that information, but I believe you can as a way of doing that, yes.
And where I need PTP, I guess I need PTP on every box in the network, but I've never enabled that. What's the support like?
Good. Pretty much every box supports it now. Yeah, yeah. It's not particularly. Yeah, it's not, every box does it now pretty much. I think it's like the 7010T doesn't do it. It's probably about it. Correct me if I'm wrong, anybody in the room, but Gerard would know. Yeah, pretty much everything, right? Yeah. So, just the challenge there is that you would need, like I said, a grand master clock to be kind of the root of the PTP sync. Deploy your own, but like I said, I'm pretty sure you can just let PTP do its thing, and it will then sync to an elected grandmaster or an elected master. I believe so. I'm probably talking absolute, but yeah. Yeah, I think you're good. Yep. Right then, thank you very much. I think that's nearly on time. I'll hand over to Alexi. Thank you.